So welcome to this vNext talk. Is everyone in here a C# developer? Or do we have any iOS native Android? Couple? Cool. So the idea here is that I want to go over some of the new features coming in the upcoming language refinements from Microsoft. So first of all, my name is Philip Eckberg. I'm here from Redify as a senior consultant working in some of the cool teams around here. So if you have any questions, please just interrupt me during the talk or send me a ping on Twitter or send me an email or just grab me whenever. I wrote a book called C# Smorgasbord. It covers some of the new things in the new compiler. It covers a lot of different things when it comes to C# and how you can be productive and do cool things. So grab a copy of that if you haven't already done that. I'm also a C# MVP, so I'm a bit biased to the C# language. I really love everything that they come out with, and the new refinements in the language is really exciting. So I want to go over some history before I go into what we are getting in the future. So looking back at what we got after the first release of C#, we got something called generics, which most of us used to create reusable and maintainable code. It's really one of the biggest things released in the history of C#, and I use it every day, and I expect that a lot of the C# developers do the same. We also got partial types, which is rarely used by ourselves. They're used in the backend when it comes to Windows Forms or WPF, for instance. Also got anonymous methods, iterators, so we got IEnumerable, we got the implementations for that in different list types, which made it possible for us to use for each loops over the generic lists and so forth. Also got nullable types, so we can use nullable integers, nullable doubles, and date times and so forth, which has been quite handy, especially when we do web development. We tend to say that it might be an optional integer or not, which makes it easier when we use nullable ints. And we've got the capability of separating the getters and setters per accessibility, so we could say that we have a private setter and a public getter. We've got static classes, which in the future was really important when it comes to extension methods. And there was a few more things coming in the second version of the C# language. So looking at this change set coming from the .NET or C# 1.0, we've got a lot of new things in the language. And when it comes to C# 3, we can imagine that we've got a fairly amount of cool things there as well. We got implicitly typed local variables, which means that we can use the var keyword. When this was released, people tended to think that it's the same as a dynamic keyword, that things weren't really statically typed anymore, but that wasn't really the case. The idea of the implicitly typed local variable is that we don't have to explicitly say that I'm getting a generic of a generic of a generic of a generic when I call a method. I don't really care what the return is. I just want that to be implicitly typed. And we've got object and collection initializers, which means that we can do var x is equal to new list, and we can say that this list contains a couple of values. We don't have to call the add method every time ourselves. It just lets us do a bit more tidy code. We've got auto properties, which I expect a lot of you use every day. It's really a good addition to the language. Coming from C# 2.0 and going to C# 3.0, auto properties just changed everything. Going from 3 lines of code and just have 1 line is quite substantial if you're working on a large code base. We've got anonymous types, which was a really nice feature to have, especially concerning LINQ, language integrated queries. So we got the extension methods, which also made it possible to do LINQ. We got query expressions, lambda expressions, expression trees, and all that. That lets us do really generic and extendable code. And there's a few more things, but these are really the biggest parts of that release. Looking at C# 4, we got dynamic binding. This is really one of the biggest changes in C# in the history, right? So we got the dynamic language runtime. We have the capability of extending the language by using dynamic invocation and expandable objects and the dynamic object to create dynamic code. And this opened up for the possibilities to use things like Iron.js, Iron Python, and Iron Ruby and things like that. We've got named and optional parameters to make it easier for us to write more readable code and understandable code. In some cases, you can argue that if you have a lot of optional variables or optional parameters, it tends to not make it as readable, but used properly, it can be really good. And we've got generic code and contravariants, and a couple of more things. As you see here, it starts to decrease in the amount of features that we get in the language updates. And you can start to think that what's going on Microsoft's side, are they deciding that the language is good enough, or are they working on something else? And this becomes more apparent when we look at what came out of C# 5. So we get asynchronous methods. This is really the biggest release in C# 5. Have anyone here done asynchronous programming using the new async and await keywords? Just a few people. So the idea is that we have our code that looks synchronous. It looks very linear, but we just apply a couple of keywords, and the compiler takes care of setting up a state machine. It creates the continuations and callbacks, and does all these boilerplate code for us. So it's really a handy and really important feature. And we've got coloring for attributes. So these are really the two things that came out of C#5. And again, we see that the amount of features are really decreasing with the new language versions. So we can think about this for a second. Why is there not so many features coming in C#5 compared to C#2 and 3? Is the language done? Is Microsoft putting their effort elsewhere? So looking at the state of the compiler. Over the years, the compiler has been extended with the generic support. We've got the dynamic binding support. We got the async and await things in there. But this is not written in a managed language, which makes it hard to extend. It makes it hard to test, and it makes it hard to make quality changes to that and be certain that we're not breaking any changes for people and looking back at what we've got before. So really, the compiler is a black box. We don't really know what's going on in there. We know that when we shove some C# code in there, something executable or something that we can link to is generated. But we can't really hook into the compiler and say, hey, I want to get some information about these code bees. I want to analyze this code and say, for instance, I want to find all the variables with the name starting with a letter A. You can't do that with the compiler today. So companies like ReSharper, they wrote their own compiler to compile C#, and they did that so they can provide us with reflection and with refactoring tools. So really, what Microsoft has been working on is something called Roslyn. And this is a rework on their compiler. So a few years ago, or actually many years ago, Microsoft did the decision to rewrite the entire compiler. And the reason that they want to do this is because they want to make easier for the future to make changes to the language. The new compiler is written in C#. So they're writing the compiler in C#, compiling the new compiler using the old compiler, which is pretty cool. So you can imagine if they were to rewrite a compiler in the future, they use the new rewritten compiler to compile the future compiler that's compiled by the old compiler. So many compilers. So this makes it easier to extend and to maintain. Just comparing working with C# and C++, I don't know how many of you have worked in C++ and can compare that to C#. It's really much nicer and easier to work in C#. And working in C# lets them do easier unit testing and make it easier for them to ensure quality. And it's open source. So they've taken the C# compiler, which is written in C#, they put that on CodePlex and let you submit feedback. They let you see how they compile the code. They let you do all sorts of things. You can pull down the compiler and make your own compiler of that. And that's really interesting to see that they're doing. You can even go in and see some of their decisions that they made when they made the compiler. So the language design team put up all their documents from meetings where they've had discussions on new keywords, new features, and all that, and you can follow the discussions in the meetings, which is quite exciting. So in C#6, with this new rewritten compiler, it's easier for them to extend the language, and it's easier for them to maintain the language in the future. So this is introducing a couple of new features. I'll be going over them in a bit more detail, but this is an overview. So we get something called primary constructors, which lets us define the primary constructor for our classes. We're just going to save a couple of lines of code. It's not a substantial change like the async and await keywords, but it's small changes making big differences. We get auto property initializers, which sort of ties together with the primary constructors, with using statements for static members, dictionary initializers, declaration expressions, await inside finally blocks. I've been awaiting that thing for a long time. Exception filters. So imagine that you get a lot of exceptions in your code and you want to handle that properly. If you want to handle an exception based on some criteria of the exception, it kind of gets quite ugly when you do that today. And they've introduced a change that makes this easier. And my favorite change is null propagation. It'll help us to avoid getting null pointer exceptions, definitely. And there's more things that might come and might not come, but let's take a look at these more in depth. So the primary constructors are there to help us define the primary constructor for our classes. Imagine in a world where your objects cannot be initialized without being properly initialized. For instance, if I have a person class, a person can't exist without a name and an age. So I say that I have this constructor here on my person class. It takes the parameter name and it takes the parameter age. All good, right? And then someone decides that I want to instantiate that. I don't really care about the domain rules. Just let me create an object. They go into the class and just put an empty constructor in there. And everything breaks. That's not really a good approach, right? So the primary constructors are letting us sort of put a constraint on the class and say that this class definition requires you to have these two parameters. Under the hood, it's going to make the same things as we've done before, but it's more enforced when you take a look at the class definition itself. So here's an example of that. We have the class person here, and in the class declaration, I'm saying this primary constructor takes the name and the age. So it's quite obvious here that I don't want anyone else to create an instance of this class using different parameters in this case. This is the lowest bar possible to create this object. Now what will happen here is that it will take these parameters and put them in a normal constructor. So for us to be able to use this within our class, we'd have to set them to our private members, for instance. So I can easily do that by declaring two private fields here, and then initializing these with the values passed to the primary constructor. And of course, I can introduce a second constructor that lets me add more things to my class. So the address here, for instance, is optional, and I can say that in this case, I'm calling the base constructor or the constructor that is the primary constructor with the parameters passed to my additional constructor. And of course, I can use these private variables that I've created up here. So looking at this, it's not a huge change, but it makes a big difference when looking at the code. It enforces the rule and says, this is really what you're supposed to do with the class. It takes these two parameters. This is what I want at a minimum when creating this class. Especially when working, for instance, in domain-driven development, where we really don't want things to exist without being properly built. So behind the scenes of the primary constructors, it'll take those parameters and generate a constructor for us using those parameters. So we see that here in the red box. We see the generated constructors. We have the same approach as we've seen before. We have the person constructor takes two parameters and sets two private fields. So it just generated this for us. Instead of us having to write this boilerplate code, we could just use the primary constructor. The next thing is the auto property initializers. The auto property initializers quite tied together with the primary constructors. So imagine that you want to declare a property, and you just want to use the primary constructor parameters passed to your object, and you want to initialize the properties with those values. So given that we have this person class, I have the name and the age. Now I want to say that I have a name property. I want to expose the name to whoever uses my person class, and I want to initialize that like this. So I can say here that I have my name property, I have a getter and a setter, so you could change the value from outside, but when I'm initializing this class, I can set that to whatever is passed to my primary constructor. And in the essence of creating true and proper read-only things, we can even say that we have a getter only, and the backing field is initialized with the value passed to the primary constructor. So I don't have to separate this and create a new constructor. I don't have to say that, oh, it's a read-only field, it's just setting the constructor. It's going to be handled for us. So again, it's just a couple of small changes that makes a big difference. And looking at what happened behind the scene here, we have this auto property. Yep.
In that case,
this one here.
Yeah, to get to is there a private setter nested?
If there's your question is there a private setter in the get only?
Yeah.
Nope, there's not. So that's truly read only. You can't change that. You could probably use reflection to do it, but there's no out of the box thing that you can do that with. That becomes more obvious when we take a look at what happens when the compiler compiles this. So we have the primary constructor at the bottom here that is generated. It's setting the backing field to whatever name we pass to our class here. And notice that we set in our primary constructor that we have the int age, the age of the person. but it's not really used anywhere outside the constructor. So it doesn't automatically create our fields for us. We have to do that ourselves. And you could argue if that's a good thing or a bad thing, but since they're taking that and introducing a compiler, so it's just like a syntactic sugar. But the backing field here is set, and you'll have a get only, so you can't really change that. So using statements for static members is a pretty interesting change. So imagine that you want to say, I want all things in system.console, all the methods, to be a part of my class. For instance, I want to call writeLine, but I don't want to specify that I'm doing it in system.console or that I'm doing it in system.diagnostics using the debugging. So the way to do that is that I say using system.console, and that makes all the static members a part of my class or part of the file I'm working in. So here's an example of that. I have my speak method here. I'm taking the primary constructor parameters name and age, and I want to simply say, here's my name, here's my age. So in this case, I could just write line, hi, my name is, I'm passing the getter, for instance, here. It's doing that by the property initializer, it gets the name from that, and I'm setting the age from the primary constructor. So in this case, imagine that I changed the using system.console to using system.diagnostics to get access to the debugging.writeLine. Instead of having to change things inside my code to find and replace all the usings of console.writeLine, I can just change the using statements. And this gets quite interesting when you do things like that, when you want to debug either in the console, in the debug window, or things like that. It also gets quite dangerous when you do this, because you really have to be careful not to just remove your using statements. Especially if you have a writeLine method inside your class, that one would have been called first. If you remove that, it would use system.console. So there's still this level of hierarchy where it goes to the first one inside your class, then it goes to the next one and next one. So this is a quite nice addition. Doesn't, again, change too much with the language, but it makes it easier for us not to be repetitive. So dictionary initializers is something that a lot of people have been waiting for. So we've had the object initializers and the list initializer, collection initializers for a pretty long time. With dictionaries, though, you have to say, this is a new dictionary, then call dictionary.add, and so forth all the time. Now we can do this quite easily as well. So notice here that I'm doing this on my member level. I'm saying that I have a data member of my class. It's a dictionary where the key is a string and the value is a string. And I'm saying, in my initialization of this dictionary, I'm saying that the key name is equal to the name that is passed into my primary constructor. So it's quite nice. It's quite obvious that they add this when it comes to primary constructors, because otherwise you'd not be able to use the primary constructors for everything, right? So in the traditional world, you'd have to create the constructor, call the add yourself, and so forth. And you can, of course, do this with the getters only. You can say that the initialization of this is just giving you the dictionary with the name is equal to the name that is passed to the primary. We're also getting something called declaration expressions. So imagine that you have code looking like this. You have anyone here use the out parameter or use code that uses the out parameter? Most of you, right? It gets pretty ridiculous that you have to declare the variable before the method call. So I have to say, for instance, in this case, I'd have to say int age and then do the method call and say out age. Wouldn't it be pretty cool if we could just do this in one line? Something like that? So we can, in this case, say calculate the age based on 1987, and if there's a result, initialize my age parameter or my age variable here with that out parameter. Behind the scenes, of course, it's going to break that out and do the variable declaration before the method call, but it's quite nice when we're coding this. It has the same function as we've seen before, and we can, of course, use this age variable after the method call and verify that it's been set. So awaits inside finally blocks is an interesting change. So imagine that you're doing asynchronous code, you're calling a web server or you're calling a database call, and they're done asynchronously. That means that you're saying, fire off this web call, and when you're done with the web call, get me back to where I was in this method. Now, you haven't been able to do awaits and continuations inside finally blocks before. And I don't know the reason why you haven't been able to do it, maybe because it's hard to implement. But with the new compilers, it's been added. What this means is that we can do something like this. So we can have our try block that runs some code that is asynchronous. We can use the await inside the catch. We can use await inside final. So imagine inside the finally block, we would be able to say, call this service when everything is done, or store this to disk asynchronously when everything is done, or clean up some resources. So it's a nice addition. Exception filters is also something that I've been pretty excited about. So a lot of cases with exceptions is that you maybe have the same exception for multiple different severities. You get a custom exception with a parameter or a property called severity on it, and based on the different severity levels, you want to do different things. So in this case, I'm saying here, I have a custom exception. The severity of this exception is 100. Now, if the severity is less than 50 or greater than 50, I want to do different things. In the old world, what we'd have to do is that we'd have to do catch custom exception and do if blocks inside there. And if we have a lot of these cases, it's going to add up and be a lot of nested cases, and it's not really going to look that good. Especially if you want to say severity is less than 50 and it's not including this part here, and so forth. So what they've done to improve this is they introduced something called exception filters. So in this case, I can say, catch the custom exception if the exception severity is above 50. And in that case, I'm just writing something to the right line, to the console, use the console right line. And of course, I can say, catch all the custom exceptions if the severity is not the one above. Again, the compiler is going to take care of this for us. It's most likely going to squash these together and do them in one catch block inside the compiled code. But to us developers, it's a pretty nice improvement, especially if we are doing proper exception handling and really catching all the exceptions and working with all the different cases. All right, so the final addition to the C# language that we've seen that we are going to see coming, which was just marked as done a couple of weeks ago, is null propagation. I imagine most of the developers doing C# have gotten a null pointer reference exception. It happens so often, especially when you think that an object is not valid without a child object initialized on it. For instance, if I have a person class, which references an address class, which references some other things, in a lot of cases, that address class is not going to be initialized by the person calling our method that expects it. So that's going to throw us a null pointer exception. So by extending this person class a bit here, I've added the address class. Now, I'm initializing Philip down here to say, Philip is a new person with the name Philip. I'm not initializing the address. So what happens now that I call Philip.address.addressLine1? It's of course going to throw a null pointer exception in our face. So what's the best approach to solve this problem? It would probably be to do something like this. To say, if Philip's address is null, just say no address. If Philip's address isn't null, just print Philip's address. Imagine, though, that Philip is passed down to a method. We don't know that it's not null, right? So in this case, we might have another bug where the actual person object is also null. So we'd have to check that as well. So we have to do, if person is not null and person.address not null, write this. Otherwise, throw an exception, do whatever you want to do with that. It gets pretty ugly pretty fast. So with null propagation, they've solved that. So they're saying, please write this out to the console. So I'm saying console.writeLine, if Philip is not null, go to the address and check if that's null. So I'm using the question mark to indicate that if that's null, evaluate the entire expression as null. This is a bit hard to get your head around to start with, but the entire expression is going to be understood as a null, right? So if Philip is null, the entire thing is going to be null. If address is null, the entire thing is going to be null. So it goes over each of these one by one. So I imagine that we're going to see a lot of question marks in our code, and it's not due to people not understanding the code. It's due to handling the null propagations. And it's a really nice addition, right? This is something that is really going to help us avoid these horrible problems. Of course, we shouldn't really allow nulls from the start, but in the light of actually having nulls in the language, we need to do something to be able to work around that. And there's more things coming to the language. Now, these features that I'm going to show here afterwards, they're really not marked as done. They're not marked as these are coming to the language. So from Microsoft's perspective, theyese are things they're openly discussing on their Codeplex side. They're saying that we want to do these features, but we're not certain how to do it or if we want to do it, really. So there may be features that are coming to the language. Includes binary literals and digit separators. Now that means that we can say, the first one here, that's the binary literal. So I'm saying I have a binary number here. In this case, it's 8. So we could initialize a byte with that number, for instance. The second one is a hexadecimal value, which I'm separating by using underscore. It's just a way to make the code easier to read, especially when working with these kinds of numbers. You could also use the digit separators for very large integer values or double values. Another thing is the expression-bodied members. What this will let us do is that, in this case, we have a rectangle. The rectangle has a primary constructor that takes the width and the height, and we want to compute the area of this rectangle. So I'm saying I have an expression here. You have not been able to do this before. So I'm using the fat arrow syntax to say, calculate the area when I call this based on the width times the height. It's a nice addition. We have event initializers maybe coming up. Previously, we haven't been able to do that either. So the same thing really goes for what we've done before with dictionaries. We can initialize our objects, but when it comes to certain things, we can't do that in the object initializers. So what we can do now is that instead of doing the event initialization after the object initialization, we can do that in the initialization here. It's a nice feature. And we can do field targeting on auto properties. In this case, it means that I can say the backing field for age is not going to be serialized. So we can do certain things like that. You haven't been able to do that before when it comes to auto properties. You can do it with normal properties, but not with auto properties. The semicolon operator is something that the F# people have had for a long time. If you're an F# developer or another functional programmer, you know that a lot of things coming into C# is sort of taken from the functional approach, because that's a really nice way of programming, right? In this case, we're evaluating everything inside the parenthesis as one big expression. So I'm saying here that y is equal to x that comes from foo. I'm going to print x out something right here, and then I'm going to return x squared. So that entire thing will evaluate to one expression, and y will be equal to x in square, or x times x. And we use params with iNumRable, which haven't been possible to do before. So params is normally used for single dimension arrays. So I'm saying that this method takes x amount of arguments, and in this case, I want to say that I'm taking a set of lists of integers, so it's a multidimensional array. This is also something that's on the table. And string interpolation. It's an interesting addition, especially if you've done things like PHP in the past or other languages where you're allowed to use variables inside your strings or your literals. So here, for instance, I can say that the person's first name and the person's last name, and then the person age, without having to do the color braces 0, color braces 1, and calling it like that. So again, it's a nice addition. It's not really huge. It's not really huge changes, but it's an improvement that lets us really express ourselves in code without using too many lines. And there's possibly more features coming. And if we take a look at this list here, combine that with the list of features that are already marked as done, it's a really nice addition to the language. And having rebuilt the compiler, I really made it possible for them to do these changes. And even though some of these changes may come in the future or may not show up in C#6, it's probably something that they're thinking about doing. And some of these features are so easy for them to implement in the language due to the rewrite of the compiler that it'll most likely show up. And having a look even further in the future in C#7, we can see a lot of changes coming based on the rewrite of the compiler, especially in the meta programming space. So there's a lot of more things that we can do with Roslyn. It's not only about getting new features to the language. In the start, I said that the language is actually, sorry, I lost track. So it's not only about the language changes, it's also about the rewritten compiler and what you can do with an exposed compiler. So not having the compiler as a black box means that we can do more things. We can do things like getting the APIs to the compiler. So the compiler is exposing their APIs. We can ask the compiler for information about code, for instance. We can do plugins that are powered with the Roslyn. So I did a proof of concept quite a long time ago where I used Roslyn to load files from disk and compile them in runtime and make them a part of my application. So by combining the approach of aspect-oriented programming and the idea of having plugins for your application where people can write code for your application in C#, that's a really interesting space to explore, especially for game programmers. I don't know how many of you have played World of Warcraft, but they have the possibility to create plugins using Lua. And imagine being able to do that in C# for certain games or certain applications. It's an interesting space to explore. And we can analyze code using the Roslyn compilers. So as I mentioned before, you can use the Roslyn compiler to say, is there a variable with the letter starting with A, the first letter being A? Or you can say that, is this variable used anywhere? Is this variable not used anywhere? Can I do any improvements in this? You can do really cool code refactoring and code analysis. And we can rewrite code with Roslyn. So what this means is, if we know the aspect-oriented programming patterns and we know what that is, we can apply that by using Roslyn. So the idea of aspect-oriented programming is that we can decorate our methods in classes and say that when this is initialized or when this is called, I want to do something. I want to do a man-in-the-middle attack. So when you call this method, give me the values first, and then I'll pass that on to the person or to the method. So that gives us the ability to hook in debugging to say that I want to track all method calls inside my application. I want to find bottlenecks. I want to do performance analysis and things like that. So having the capability of analyzing code by performing static code analysis and doing code rewrites, that's a really interesting space to explore. So in summary, C#6 is really introducing a lot of nice and handy features. We're going to see a lot of changes coming up in the future versions as well. And it's really nice to see that Microsoft is putting a lot of effort into making it one of the best programming languages out there. And having seen that it dipped in the features added in C#4 and 5, and we now see this huge change in the language, we can see that Microsoft is investing a lot of time and effort into making it one of the best languages. And all these changes are really a lot if we compare to what has happened in the past. And it's really a cool addition. So the Microsoft Compiler Platform, which is also known as Roslyn, makes it easy for Microsoft to improve the language. Not only by adding new language features or by adding changes to the syntax, they can do a lot of things. So they can expose the compiler to us, they can let us do plugins, let us do code analysis, let us write plugins for Visual Studio, for instance. So imagine being able to say, to go into the NuGet package manager or the extension library and say, I want to pull down this refactoring plugin. I want to enforce a certain plugin in my project. So you can have your entire team forced to pull down that NuGet package when they fetch the code from Git and just have that as a part of your normal development process. By using Roslyn, you're allowed to do things like that since you have the compiler just by your hands. Do we have any questions? I can show you the new Visual Studio 14 if you want to see that, and some of the new features that they've added do the real things. So if you don't have any questions.
One question on that.
Yep. Sure.
Because it's pretty closely tied version-wise, you've got version of C# doing. So you write your Roslyn code with C#6 and then you have to analyze C#7 code. You just want to write so that you can features it out. So
your question is, if I use Roslyn now to analyze code, would that be future-proof for C#7? So I imagine that it would be the same as if you use the old compilers. So you can't really use the old compilers to compile C#3 when it's a C#2 compiler, right? Because the features aren't understood by the compiler. So there will be version changes of the compiler, and you'll have to use the version corresponding to the language to analyze it. But because what happens behind the scenes is that it compiles the code. It's done in multiple passes. And since they're using C#, they can do easier multi-threading and do the passes faster. But what they're doing is that they're letting you hook into that process. So when they're doing some of the passes, when they're analyzing the code or compiling the code, you can hook into that and analyze the code. And I'd be very surprised if you couldn't do that to some extent with some of the code in C#7 or whatever the next version of C# is. Because the first thing that you do is that you say, give me the code here and convert that to a syntax tree or a semantic model. And what happens is that it just takes everything and makes a tree out of it. So it's not really compiled down to a DLL or to IL, it's just analyzed code. So as long as it's followed the structures of C#, it should work. But I'm not certain.
I'm interested for the static using, because that seems to be almost filling a similar space as you would with a normal interface implementation of the class, but coding it directly into your class. What's the thinking behind that? Because I can see kind of the facility it gives us, but it sort of makes me feel that people will be going, well, I could do it with an interface, or I could make all my methods static, put it on a namespace, and switch my namespace out from the consumers, which is kind of an awkward pattern. I'm not sure where they were going.
So the question is, why don't we just use dependency injection and use interfaces instead of using the static members?
Well, it's more, what was their thinking outside of the base class usage patterns around things like a console.writeLine implementation of statics, because it's going to give people a pattern that may or may not provide us better code. It feels like there's a code smell there waiting to happen by the use of that. So I'm just interested in the background.
You're asking what their thinking is outside of just using it for console writeLine and debugger writeLine. So imagine things like datetime, for instance. If you want to swap over to some other datetime handler, there's datetime offset or things like that. If they have the same properties or the same methods on them, you could make that as part of your application. So you can say using system.datetime, or you can change that out. But I see what you're saying when you're saying that it's an awkward pattern, and I wouldn't want to see that in my application. I can't answer for their thoughts around it, but when doing things like debugging and logging, it's pretty nice to just be able to swap it out based on what I want to do for what kind of logging I want to do. So imagine that I have a method called log. I have two different implementations. I could either use dependency injection to inject the logger, or I could just change the namespace and have it log different ways. It makes it easier so when you're doing development.
Because if I'm changing a namespace, I'm changing my code to get what should be an orthogonal concern into my code base.
Sure.
Yeah, so I don't know, that's the one that smells to me. I'm not quite sure.
It might be a code smell. You should probably be careful when using it. I wouldn't advise everyone to just go ahead and use that everywhere, but they have the design documents on their CodePlex site. So if you want to dig down into what their thought process is, I'd go ahead and have a look there. Any more questions? We just want to see the new IDE. So it looks like the old one, except the addition of the language features. So what you have to do when you download Visual Studio 14, and just as with the previous version, Visual Studio 2013, the version number isn't in correlation to the version of the IDE's end version number. So this is maybe going to be Visual Studio 2015, but it's called 14. I don't know why. I think the folder is called 14 or something. They use some incremental versioning number. Anyways, so what you have to do to enable these experimental features is that you have to go into the project file and say the language version is experimental, which enables us to do all these cool things that I've showed you before. I'm just reloading the project. Let's go into the program.cs. Unless it crashed. Didn't? Perfect. So I'll just make this a bit bigger. There we go. So here you can see that I'm using the primary constructor. I have the person down here with the string name. I'm invoking that up here. And let's say that I want to do that, the speak method. So let's do public void speak. Sorry, wrong language. It's one of the non-benefits of being non-native English. I need to have 2 languages on my keyboard with 1 language layout. So what I can do now is that what I've showed you before, I can introduce a private variable. So notice that I'm using the underscore here. The reason for that is that there's no way for me to say name is equal to name here because it's already defined. There's a discussion going on if you really should use the prefix underscore or not. ReSharper enforces this, but it's like using m underscore or doing the Hungarian notation. So some people are against it and some people are pro. Let's just use it here. So I can do right line and say, hello, my name is, and then supply the name here. And as soon as I add the using statement on the top here, that should work. I can say system.console. This should be able to compile. So see that worked? So I can call Philip.speak. When I run this, it says, hello, my name is Philip. So that's cool enough. Now, let's say that I want to replace this with system.diagnostics. Compile it again. Maybe it's debugging. Sorry, system.diagnostics.debug. And that has the right line as well. So now if I put a breakpoint in here, run the application, it should show up in my debug window if I'd had that open. Debug window. Output. There we go. Hello, my name is Philip. I don't know if you can see that down there. So by just changing that namespace, it gave me a different output. But in this case, it's not using the string.format. So I'd have to do some more changes to my code to make that work. But it still compiles and still works. Now the interesting thing here is what happens if I introduce my own method called writeLine. So let's say that I do that in here. Public void writeLine string input params string input 2. We compile this. Oops, sorry. Oh, let's just do 1 there. Sorry. Just to make it compile. Still compiles. And if I debug this again, it does not show up in the debug window. So that means that it's calling that other method. So that's also something to be careful about, right? You can introduce the namespace and say that I'm using all these static members, but then you introduce a method with the same name and that overrides that call. So you need to be cautious about the features in the language. But I imagine that the tooling for this will improve in the future. So you get suggestions saying that you have a collision here. It could give you some detailed information about that. And that's easy enough to do with a compiler. So you can say, with the exposure of the compiler APIs, you can say, is there another method that I have access to that has the same name and the same parameters? Give me a little icon like this up here. So in this case, it actually does say that system.diagnostics.debug is not being used.
So if you were to define your own extension methods of existing object, you would be using the extension method as the extension of the static user.
I'm not sure I follow.
So if I create an object called C#6.static object, and then I create an extension method of static object called writeLine, could I then use the using to use the extension method of the object that I've defined?
So you're asking if I introduce so if I have this class down here called class person, and I'd introduce an extension method for person with the extension method called writeLine, what would happen?
Yeah.
I don't know, let's try.
If you create well, you need a static class for your
Sure.
extension method.
Yep.
Put a static extension method of the person,
Yep.
writeLine, and use that namespace. Is it going to take it from the using code? So
Yep. I'm pretty sure. So So if I make a static class with an extension method, and can I use the static using statements to include that as a part of the person class?
By the using.
Yeah. So by the using, you'd like to include the extension methods for that type.
I'm wondering if it does. Because that basically means you've got an additional level of composition whereby I can say I've got.
So I imagine that being possible. I don't see why not, since it's a static class and it's a static member, and the first parameter defines that it's a part of that, it should work.
Which basically gives you an extension point.
So why would you do that though, right? Because if you have access to the code for the class, why would you do something in an extension method and not just do it in the class?
Well, because people are fairly insane when they try and write C# code. So we see some crazy stuff around extension methods, and I'm just looking at exactly what that means from an extension method point of view, to be able to include an arbitrary set of methods via using on an object, and then have those compositionally injected into a bit of code. So interesting. I don't know.
I haven't tried doing that, so I haven't tried doing the extension methods and then make that as a part of a using for static members. It probably works, but I wouldn't advise doing it, especially not if you have access to the class itself. It wouldn't make much sense. I would probably see people doing it. Let's leave it at that. Sorry?
So if you made a class and don't write the generic first, where does...
So you're asking about inheritance when it comes to classes using the primary constructors. So let's see here what happens. In this case, if I compile this, it's going to say that no arguments. There is no argument given to the corresponding that requires blah, blah, blah. So it's the same errors that we would get if we inherit from a class without calling the base constructor. So you can say here, I have the string name, and I'd imagine that you'd be able to say name here. Works. So they've probably thought about that, right? It's important that in everything that we've been able to do before still works without having to go back to the old patterns. So it's a nice addition, and they've really thought about things like that. Any more questions? All right, so thanks very much for listening to me. I'll put up the recording for this on YouTube, and I'll send out the link to everyone, I guess. Thanks.